We are on to solubility product constant. This is the TA demonstration preparing the stock solution. For this, we will need concentrated sulfuric acid in a dropper bottle, iron 2 ammonia sulfate, a 100 ml beaker, and our DI water. To start, we need to calculate how many grams of our iron 2 ammonia sulfate we need in order to make a 2 millimolar solution. Here I have pre-weighed our 0.785 grams of iron 2 ammonia sulfate, which is what we will need to make 1 liter our 2 millimolar solution. So I can take this and add it to my 100 ml beaker. Then I will take my DI water, measure out 50 milliliters in my 100 ml graduated cylinder. Now with my water, I can take and rinse my weigh boat to gather all of our solid. Next, I need to add 1 milliliter of our concentrated sulfuric acid. As you should know, you always add your concentrated acid into water, which is why we put our water in first. Then we can take, swirl the solution. You can also use a glass stirring rod to help get at some of the solid in the corners. And we need to swirl until all of our solid is dissolved. Now that there is no flecks of solid left in our solution, we can take and add this to our 1 liter volumetric flask. Next, we want to dilute our solution in our volumetric flask up to the 1 liter mark up on the neck of the flask. We'll be using distilled water. To ensure that I got all of my solution, I will be rinsing my beaker with distilled water. Now that I have rinsed my beaker several times, I will take and dilute up to the 1 liter mark on the neck. Now that I have diluted my solution up to the 1 liter mark on the neck, I have taken my rubber stopper, capped the top of the flask, and then now I can invert the flask several times to ensure that the solution is thoroughly mixed. And now we have our stock solution. Each pair of students will need 50 milliliters of this solution. Now we are moving on to our Beer's Law plot preparation. To do this, we need to prepare our solutions for the plot. I have here my blank. In order to make this, I'm going to need 10% sodium acetate. I have 1 milliliter of that in my graduated cylinder, which can be added to my flask. Then I need 10% hydroxylamine hydrochloride. I have 1 ml of that. And then lastly, 110 phenanthrene monohydrate, 0.1%. I need 5 ml of that, which I have in this graduated cylinder. That is added to my solution. Since this is my blank solution, I will not be adding any of my stock solution. Instead, this will just be diluted using distilled water. So I will take and dilute this to the 100 ml mark in the neck of my volumetric flask. And now I have my blank solution prepared. I can cap it with my rubber stopper so that nothing happens, nothing can get in. If I accidentally tip over the flask, I should not lose any of my solution. Next, I will be moving on and creating a 20 micromolar solution. The only difference between this And my blank is that for my 20 micromolar solution, I will need to be adding my stock solution and diluting with water to create the 20 micromolar solution. For this, again, I need to add my sodium acetate, hydroxylamine hydrochloride, and 110 phenanthrene, just as I did with my blank. So I have my 1 ml of my sodium acetate. I have my 1 milliliter of hydroxylamine hydrochloride, and then my 5 milliliters of my 110 phenanthrene. Now when I created my blank, at this step I simply diluted, but since we are making a 20 micromolar solution now, I will bring in my stock solution. I have my 10 milliliter glass pipette. As you can see here, our pipette reads from 0 to 10, meaning we do not want to let the tip of our solution go into volumetric flask. So I'm going to measure out up to the 9 milliliter mark, and then I need to only allow the solution to go down to the 10 milliliter mark, not all the way down to the tip. The reason why I'm only going to be filling to the 9 is because in order to achieve my 20 micromolar solution from my 2 millimolar stock solution, I need to perform a 100 times dilution, which means since I have a 100 ml volumetric flask, I need only 1 milliliter of my solution. You should be able to find this out as well in your calculations. For your next solutions, you will need to calculate how much more of the solution you will need to use. Right now, I am rinsing my glass pipette with my stock solution. This is so that I get a more accurate reading. Now that I have rinsed 3 times, I can go through and make my actual measurement. So I will pull up in solution past my mark, undo my pipette bulb, and then quickly put my finger over the end. That way I can slowly let solution out from the pipette. Now that I have stopped at my 9 ml mark, I can take and move to my volumetric flask, and then slowly let out my 1 ml of solution. As you see, we now have an orangish red complex color formed in our volumetric flask. This is from the 110 phenanthrene mixing with the iron 2-ammonia sulfate from our stock solution. Now can be diluted using our distilled water to the 100 ml mark. Now that I have my solution, I can take and cap it with my rubber stopper. Now that it is thoroughly sealed, I can invert to mix the solution. Now that my solution is thoroughly mixed, I can go and set this aside, leaving it capped. I can prepare my 4 remaining solutions. For the next 4 solutions, you should do the calculations yourself in order to find out how much more stock solution you will need to use in each of them. Based on my calculations, I will need to use 1 milliliter more for every 20 micromolar increase above the last. So in this case, we will need 2 mils for the 40 micromolar, 3 mils for the 60, 4 mils for the 80, and 5 for the 100. Here are all 6 of our solutions prepared for our UV Vis. So we have our blank, 20, 40, 60, 80, and 100 micromolar solutions. These all need to sit for about 5 minutes now that we have thoroughly mixed them. And if you observe, you can see that our 20 micromolar solution is a very light orange. Our 100 is a very deep orange, and it is a gradient between them for our 40, 60, and 80. Once they have sat for 5 minutes, we can put our samples into cuvettes, go to our spec 200, and we'll be able to start recording absorbance for our beer's log plot. Now I need to prepare my solution using my saturated solution of iron oxalate. In order to do this, I'm going to need a long stem funnel, my piece of filter paper that I take and I have folded in half and in half again in order to make a funnel, my long stem funnel. But first, I'm going to need to measure the temperature of the solution. This is my solution that I prepared last week in lab. I have my thermometer into my solution. My solution is reading at 20.9 degrees Celsius. I can mark down the temperature. Now prepare my long stem funnel with filter paper. The solid has settled on the bottom. This means that I can go ahead and start filtrating. If your solution is not settled, you will need to wait and give it time in order to settle. So I have here a clean 100 ml beaker. I will put my long stem funnel into there, take my solution, and pour into the filter paper. I want to let my solution drain. As you can see, I am holding my long stem funnel by hand. I could, however, go ahead and use a ring stand with an iron ring attached to it. Once my solution is thoroughly drained in this batch, I can go ahead and place it inside my iron ring. I can let this sit and stand and drain, and I do not need to hold it manually. With this part, I now just need to keep going back with my stock solution, filling up the funnel. I do not want to fill the funnel beyond the capacity of the filter paper, so this is going to take some time to slowly drain. As I go, I will need to raise the funnel up in order to make sure that I do not overfill my beaker or dip the neck of the funnel into the beaker. I'm only going to be filtering about 80 to 100 mils of it. This is so that we have enough of the solution in our beaker, but we also do not want to let our solid go into our beaker. In order to prevent this, we will still keep some solution in our flask here to keep our solid behind. Our solution does not contain any solid particles inside of it. It is completely clear going through, slightly tinted yellow as we would expect from this solution, but this means that since we do not see any presence of solid particles, we do not need to perform a second filtration. If you do see solid particles in your solution, you will need to go back through and refilter until you have no solid remaining in your solution. Now we are prepping our solution of our saturated iron oxalate. To do this, I'm going to need my 10 ml graduated glass pipette. Since my glass pipette already has some traces of our stock solution from before, I'm going to take a little of my filtered saturated solution, pour into a separate beaker to use as a rinse beaker. So now I can go ahead in my rinse beaker, draw up the solution, and just like with a burette, I can go ahead and roll around to make sure that I get rid of all traces of it inside of it. You do not want to let any solution go into your pipette bowl. So now that we have rinsed our pipette, we can go and get 5 milliliters of our solution. Just as before, we are using our thumb in order to cap the glass pipette. Take and add my solution to my volumetric flask. I want to stop at the 10 mil mark since I only need the 5 milliliters and we do not want to use a solution that is in the tip. Now that we have solution in our flask, we can label it as our saturated solution flask. Next, we will need to add our sodium acetate, hydroxylamine hydrochloride, and 1,10-phenanthroline as we did previously. So I will need 1 ml of my sodium acetate, then 1 ml of my hydroxylamine hydrochloride, and lastly 5 ml of 1,10-phenanthroline. As you can see, we have the deep orange, just as before, my distilled water, and dilute up to my 100 milliliter mark. Now that I've filled to my 100 milliliter mark, I can take and stopper my flask, and then I can begin inverting to mix. Now that my solution is mixed, I'm ready to add it to a cuvette and use it on my Spec 200. Now that we have all of our solutions, I am going to prepare our cuvettes for measurement on our Spec 200. To start, we take our blank and our blank cuvette. You can either pour directly from the neck of your flask, or you can take and grab using a plastic pipette. If you use a pipette, you will need to rinse the pipette between each flask. We are taking and rinsing our cuvette just a few times in order to make sure that our cuvette is clean. So here is my beaker that will take all of my rinses. Now that we have rinsed this flask, I can fill it about 2/3 full with solution. So now I have my blank cuvette. As you notice on our cuvettes, one side has an arrow. This will be important later on. The rest of our sides are all clear. So I can take and I will set each cuvette by the solution it belongs to, so I do not lose track of which ones are which. And I will go through and rinse the cuvettes using each of the other solutions. So now I have poured and rinsed every cuvette. I have then poured and filled them about 2/3 to 3/4 full with each of the desired solutions. Now we can move on to using our Spec 200. Here's our Spectronic 200. You'll be provided with instructions on how to take measurements and how to start up the Spec 200. Just to quickly review some of the buttons, here is our knob which controls our absorbance wavelength. We already have it set to the appropriate wavelength we are looking for at 508. We have our 0 button, and then we have our arrow keys and enter key for when we need to use them. Your arrow keys can be used to change your absorbance up or down by 1 value. This is where we'll be placing our cuvettes in order to do our measurements. Before we do that though, we need to take our cuvette, and you can see on our cuvette we have one side that is frosted with an arrow on it. So we need to take this face and aim it in the appropriate direction. The other faces are all clear. So in this case, with our blank, we take the frosted side with the arrow and point it towards our optical lens in here, which will be creating our light. So I have my frosted side facing towards the light of the Spec 200. Now that it is in there, I can take and close, press my 0 button. Now we are going to be measuring our absorbances using our Spec 200. You'll be provided with a sheet with instructions on how to take the measurements. To go over quickly, we have our knob which covers absorbance wavelength. We've already adjusted it to 508 nanometers, which is where we need it to. So now we can open up our cuvette holder, take our cuvette. As you can see,
our cuvettes have a frosted side with an arrow. That arrow is important because it tells us which side to face towards our optic. We need to make sure that our cuvettes are clean, so we can use CHEM wipes to go through and wipe down the sides. This is to remove any form of dust or other liquid sitting in the way. Our absorbance is reading at 0, but we still want to perform our 0. While we wait, we can go ahead and clean our other cuvettes to remove any form corruptant on it. Our Spectronic 200 is zeroed, so I can take out my cuvette and begin my absorbance readings. First with my 20 micromolar. As you can see, our display changes and reads accurately just by placing the cuvette in. Our 20 micromolar is at 0.23 absorbance. Putting in our 40, it is reading at 0.44. Now our 60 is reading at 0.66. Our 80 is reading at 0.87. Our 100 reads at 0.88. Now with all of these absorbances, we can go ahead and create our Beer's Law plot, and then we will use the Beer's Law plot with our now saturated iron solution, reading its absorbance at 0.64. And so now we can go ahead and find out the concentration of our saturated solution that we diluted in our volumetric flask and work our way back in order to find our concentration of our true iron oxalate solution.